Hello, good day. How are you today? You're good, right? Okay. Are you ready for today's lesson? You are? That is good. So today in mathematics, we are going to be looking at simple equations and variation. Okay? Our topic for today in mathematics is on simple equations and variation. So are we ready for the lesson? We are with our books and our pencils or pen to get into today's lesson, right? Okay, good. So on that today's lesson, we're going to be looking at some simple equations, formula substitution and change of formula, binary operation, and variation, okay? So first, we're going to be looking at how to solve simple equations. If you have an equation like this, how do you go about it? If you are presented with an equation like this, 2x plus 5 equals to 11. Now you have to look for x, okay? You have to find x. So first you are going to look for a way to isolate x because it's just x you're looking for, okay? You're looking for this variable x. So you are going to first of all subtract 5 from both sides. To isolate only this number first, you're going to subtract 5 from both sides, okay? Whatever you do here, you're doing it at this other side also. Do you understand? So 2x plus 5 minus 5 is equals to 11 minus 5. Remember, whatever you're doing at this side, you're doing it also at this side, okay? So you simplify further. Plus 5 minus 5 is going to give you 0, okay? Remember, plus and minus is equals to minus, right? Minus times plus is equals to minus. Plus 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 is equals to plus, and minus times minus is equals to plus. You remember that? So now we have here plus 5 minus 5. This is just like 5 minus 5, okay, is 0. So you have 2x equals to 6. How did we get the 6? 11 minus 5 is going to give you 6, okay? So we have 2x equals to 6. Remember, is x we're looking for. We're looking for this variable. So to isolate x, we're going to divide both sides by 2, okay? Dividing both sides by 2, 2 cancel 2, you're left here with x. 6 over 2 here, 2 cancel itself is 1, 2 cancel 6 is 3. So x is equals to 3, okay? Do you understand? When we arrived there, we wanted to isolate x. So we divide both sides by 2. So 2 cancel itself, we're left here with x, and we have here 6 over 2. 2 cancel here is 1, 2 cancel 6 is 3. So x is equals to 3, okay? So if you input x into this place, you are going to see that this answer is correct. Do you understand? 2 times 3 is going to give you 6. 6 plus 5 is going to give you 11. So you can see that we got the correct answer. If you don't want to use this long method, you use this process. 2x plus 5 is equals to 11. You just move 5 over here, and when 5 is crossing over the equal to sign, if it's plus, it changes to minus, okay? It's still the same with this though, but this way you're moving the 5 over. So when plus 5 goes over, it changes to minus 5. But if there was a minus sign here, if it's minus 5, when it goes over, it changes to plus 5, okay? Don't be confused. So we have 2x plus 5 equals to 11. We're going to move 5 over to this other side. So it changes to minus 5. So you have 2x equals to 11 minus 5. 11 minus 5 is 6, right? So we're left with 2x is equals to 6. Now we want to isolate x. We divide both sides by 2. You divide both sides by 2. So 2 cancel 2. We are left here x, and 6 over 2. 2 cancel itself is 1. 2 cancel 6 is 3. So x is equal to 3. You can see we still arrived at the same answer. So it's the same thing, okay? Whichever way is easier for you to understand, you use, okay? Do you understand? Now let's look at another equation to help us understand better. Here we have 3y minus 7 is equals to 20. What do we do here? 3y minus 7 is equals to 20. We are looking for y, right? The variable here is y, and we're looking for y. And here we have minus 7. So instead of subtracting, we add 7 to both sides. We add 7 to this side and also add 7 to this side. Whatever you're doing here, you're doing it also at this side. Okay, so we have 3y minus 7 plus 7 is equals to 20 plus 7. Minus 7 plus 7 is going to give you 0. Minus times plus is minus. Okay, you remember. Minus times plus is minus. Plus times minus is minus. Plus times plus is plus. Minus times minus is plus. You understand? So here we have minus 7 plus 7 is 0. So, and 20 plus 7 is 27. So we are left with 3y is equals to 27. To isolate y, what do? We divide both sides by 3. Okay? You divide here by 3, you also divide 27 by 3. So 3y divided by 3 is equals to 27 divided by 3. Whatever you do at this side, you also do it at this side. Okay? So 3 cancel 3, you are left here with y. And we have 27 over 3 here. 3 in itself is 1. 3 in 27 is 9. So y is equals to 9. Do you understand that? It's easy. Okay? So next we're going to be looking at formula substitution and change of formula. We do know what a formula is, right? A formula is a mathematical expression that relates different variables. It could represent a law, a rule, or a principle. And substitution involves replacing variable with a specific value, okay? Like the previous equations we did. We found the value of x. We can replace x with the number we got. We found the value of y. We can replace y with the number we got, okay? So if you have an equation y is equals to 2x plus 3 and you substitute x as 4, you can get y is equals to 2 times 4 plus 3 is equals to 11, okay? That is substitution. You have a variable and there is a value that replaces that variable. And change of formula is, it means rewriting the formula to express a different variables as the subject, okay? Like here we have the area of a circle is pi r squared. When you're looking for the area of a circle, it's pi r squared, right? You can rewrite this formula r equals to the square root of a over pi when you're looking for the radius, okay? You know r represents the radius in the circle. So if you're looking for the radius, it's the square root of a over pi. Do you understand? We also have the area of a rectangle. The area of a rectangle, to get it, is length times width, right? If you are looking for the width, it will be width is equals to the area over length. So this is how formulas are changed, okay? Do you understand? I hope we are not confused. So now we're going to be looking at binary operation. Binary operations are mathematical operations that involve two elements, okay? Commonly, these operations are addition, subtraction, multiplication, and division, right? Now let's look at simple binary operations. We have the addition is combining two numbers to get the sum. Remember, addition is adding two things to get a result. For example, 3 plus 4 is going to give you 7. You added 3 and 4, it will give you 7. So it's combining two numbers to get a sum. We have subtraction, taking one number away from the other. Subtraction is taking away, is minus. For instance, you have 8 minus 5, it will give you 3. Let's say you have 8 oranges and you take away 5. You are left with 3 oranges, okay? Multiplication, finding the product of two numbers. For example, 2 times 6 is going to give you 12. Multiplication is about finding the product of two numbers. 2 times 6 is going to give you 12. We have division, dividing one number by another. For instance, 10 divided by 2 will give you 5. So binary operations are fundamental in various mathematical concepts. This is important, okay? And knowing it is important. These operations are used extensively in solving equations, expressing mathematical relations, and performing calculations. You saw that we use these operations in our simple equation solving, right? So knowing this is very important, okay? So next we're going to be looking at variation. Variation. A variation is a relationship between two or more variables that describes how one variable changes in relation to the other, okay? There's the direct and inverse variations. That's what we're going to be looking at. In direct variation, as one variable increases, the other also increases proportionally. And in inverse variation, as one variable increases, the other decreases proportionally. Okay? Do you understand that? In a direct variation, one variable increases or decreases proportionally with another, okay? And in inverse variation, one variable increases as the other decreases. So in direct variation, if y varies directly with x, the equation is y is equals to kx. K here is the constant, okay? The k is the constant, okay? So if y varies directly proportional to x with a constant of 2, it will be y is equals to 2x. Do you understand? If x varies directly with y, the equation will be x is equals to ky. The k doesn't change, it's the constant, okay? If a varies directly with b, the equation is a is equals to kb. Any letter, okay? Any letter you use, any variable you use, okay? Now in inverse variation, if y varies inversely with x, the equation is y is equals to kx, okay? If y is inversely proportional to x with a constant of 3, the equation will be y is equals to 3 over x. Do you understand what I'm saying? If x varies inversely with y, the equation is x is equals to k over y. If a varies directly inversely, if a varies inversely with b, the equation is a is equals to k over b. The k doesn't change, okay? It's the constant. So we're going to be looking at some examples to help us apply this. Okay? Are we ready? Here we have indirect variation. Y is equals to 3x. If x is 4, what is the corresponding value of y? Now we are looking for y. You remember the direct variation, y is equals to kx. The k is the constant, and here the k is given as 3. So x is given as 4. We are looking for y. So y is equals to k, which is 3, times x is 4, which is 4. So 3 times 4 is going to give us 12. Okay? So y is equals to 12. Do you understand? Now for the inverse variation, xy is equals to 12. If x is 2, what is y? You know the inverse. This is the inverse, right? Y is equals to k over x. Now the constant is given, which is 12. So y is equals to 12 and x is 2, right? So over 2. So 12 divided by 2 is going to give you 6. 2 into is 1, 2 in 12 is 6. Okay? So y here is equals to 6. Do you understand this?